Hurricane season is upon us, and over the years, Barbadians have been impacted by these natural disasters. Maybe like many others who have burning questions to ask, such as, what does it take to track a hurricane? What's the importance of a weather radar? And what does it take to be a Met officer? Well, to answer our questions is Director of the Barbados Met Office, Sabu. Here he comes for this exclusive. Good morning.
Morning.
Sabu. How are
Finally,
you?
I'm
Yes.
good.
Good to see you.
My name is Sabu. I'm the Director of the Barbados Meteorological Services. Nice to meet you. Hi.
And where are we?
We are at Castle Grant, St. Joseph at the radar facility. Brand new radar, a great project that started way back in 2021 as a process. But the actual decommissioning and installation of the new radar began in 2022, January, like last week in 2022.
And I'm seeing it's called the Doppler Weather Radar. What's the importance of this particular radar?
Yeah, it's a really nice sign, isn't it? So this is really important. It's part of the National Early Warning System, one of the components. There are many other components, but this is a very critical one. The weather radar is used basically to detect precipitation, not just that's occurring over Barbados, but as far as 400 kilometers away from Barbados. Yeah, 400 kilometers. That's really far. But it also detects winds as well, because it's now dual polar, so we have the ability to detect even better classification of the actual precipitation objects.
And with hurricane season upon us, I'm sure this is very, very critical, being able to predict those systems in particular, right?
Yeah, I mean, it really does help. Now, I mean, we don't have to tell the public that years ago with the older radar, we had a lot of difficulty trying to keep it maintained and operating. And I think before we upgraded this one, we did get it back working, and it worked for just about a year or so. And so that's testimony to the fact that we learned a lot of the lessons from the past. Why it wasn't working, how to mitigate those issues in the future, and how to apply those same lessons we learned to this new one to ensure it keeps working.
Should we go up?
Oh, that'll be fun. Come on, let's go.
This is exciting. We are about to climb the Doppler Weather Radar, which is the second highest point in Barbados, the first being Mount Hillaby.
Every time we climb these stairs, we keep asking ourselves, is it 100 feet, 150 feet? It depends how many times you go up and down. That distance changes. So if you've been up and down these stairs 10 times a day, it's like, I think it's 200 feet. But it keeps you in great shape, right? So during the whole great project, we had to be going up and down these stairs at least 20 to 25 times a day.
Wow.
I can tell you, it put you in fantastic shape. I enjoyed it. But sometimes you didn't enjoy it when you have to actually move really heavy objects, and it's you and someone else at the lower end, and you're just struggling to go up these stairs like this. Oh. And so when we reach a landing, we'll take a break there, but then we have to keep struggling and going up. And as you can see, if you get a shot of that, you can actually see through the stairs. So it's kind of like you're going up and floating on air. So another landing. You can see the structure is in really good condition. It's been here since 2008, and we tried our best to keep it in good condition because, like in everything, if you don't have good footing, whatever is on top will fall.
Yeah, solid foundation is always needed.
In everything. You see, I'm out of wind, and I've been up here now.
I kind of am too. But this is a very beautiful view.
Oh yeah, you gotta get a shot. So, I mean, we occasionally try to cut the trees tops down, but we will not interfere with the root systems. That's important. Where the radar sits, on the edge here, it's like a cliff right around. So these trees and roots are really, really important. They must stay, but we keep the tree tops down so that it doesn't cause any kind of beam blockage or anything like that. And it's good visibility too. And mind you, there's a lot of mildew that will build up on the dome and stuff, so also keeping the tree tops low and away, it actually helps with the slowing down with the buildup of mildew.
Why was this location selected for the radar?
Well, it's one of the highest spots on the island, apart from Mount Hillaby. So once we construct and go up on this tower, we're essentially above all of the high points of the land. And so when we do the scan, 360 scan like this, at zero azimuth, we get a full sweep right around with no blockage of the radar beam. Unfortunately, trees are too tall, but you can actually see the airport from here. That's how we communicate with radar, by the way.
Okay.
It's a direct connection we have with this dish over there. You got to get a shot of that. I know the camera guy, he's feeling a little woozy. He doesn't want to lean over the top edge here. So we actually communicate directly with the radar with this link. And I remember when we originally installed this, we didn't use a lift. So it was myself and two other really strong guys, or stronger guys than me, that we would come and we came and we would actually was holding this thing, and one guy was like leaning over with one of the safety harness and stuff, and he was bolting this. It was crazy. I don't know why we didn't use a lift, to be honest, but the second time around we did. So I forgot to mention one other thing. Well, these metal sheets you see here, that's actually sitting on the base ring and the dome. Those were really rusty. I mean, because where we are is very humid, a little bit of salt in the air, so they actually started to rust through, particularly ends. And so the whole upgrade process, it was an opportunity to change those sheets, because we thinking about the long haul, the long run. If you don't do it now, doing it in the future is a problem, because then you have to take down the entire dome, and you can't then put back up the same dome. You have to get a new one. And so it was a really wonderful opportunity to do that. And so you can see the sheets are really awesome, look really nice.
This is where it gets exciting. The Chief Met Officer is now about to take our team into the control room of the Doppler Weather Radar. Anyone entering this room must be accompanied by a member of the Barbados Met Office, and there are some safety precautions.
This room is called a control room, and it's the original room. We just did a paint job on it. There was nothing wrong with the room. It's in pretty good condition, so we just reused it. And I need to share with you and our audience what these signs mean, because they're really important for you and for the audience. It's really loud inside, and so they recommend wearing earmuffs. And no fire, please. No smoking. Don't light anything inside here. Nope, you're not allowed, not unless you are accompanied by a member of the Met Office. This is very serious. There is radiation and magnetron and magnetic stuff inside here. And so if you have a pacemaker or metal within your body, you should let us know before entering in here. So do you have a pacemaker?
I don't have a pacemaker.
Any metal?
I don't think so.
Do you have a pacemaker? Do you have a pacemaker? And this means it's radiation going on. This is a radioactive system. There's no leakage of radiation here. We test it every time we come in with a radiation detector. There's no leakage. And this just means that it's actually a radar facility. Okay, are you emitting radiation? Sorry. We're going inside. So what we're gonna do, I'm gonna go right on the landing floor, and you guys come right in and give you a security and safety briefing, okay? Ladies first.
So now we made it inside of the control room, and it is a bit chilly in here. And I'm seeing some structures here as well. Can you explain what some of these are?
Oh, it's kind of nice, you know, compared to outside. But anyway, so I'm gonna give you the security briefing first. That's important. Before I start, I need to tell you, it's going to become a little annoying sometimes. You're going to hear this beeping in the background constantly, so we do apologize for that. That's important because those security features are going on. They're actually making sounds because it's detecting motion outside, away from the building, inside the building. This is monitored 24/7. Okay, so first off, their fire extinguisher is here. To let you know where it is. And there's an emergency stop switch here in case there's emergency on the right. You also have another emergency stop here, and there's another one that I'll show you on the other side. Also see watch where you're walking, don't trip please. And this is the wave guides, which I need to let you see, because on this side is a warning sign. It's very hot. Please don't touch it. It's gonna melt your skin off, okay? So let's come on, be really careful. So the original radar, well, the first one was actually 3 cabinets. Now you're seeing 2 cabinets. It was transmitter, there was the receiver, and the antenna control unit. But now things have become more digitized, so it can condense a lot of equipment into the what we call the signal processor. I'll show you what that is, but it's going to keep a bit of noise as they open. But now we have the transmitter, I said, and then the antenna control unit is kind of up in the pedestal now, and the receiver is here. And so a lot of communication between the antenna control unit and the receiver happens in the signal processor and the digital receiver. The black thing, like I mentioned, is the waveguide. It's dual polar now, so there are 2 actual black square tubing pipes that go into the roof. Before there was one with the old system. And so we had to make this hatch much bigger, which means we had to cut a much bigger hole in the roof. And so you can imagine when we took the dome off and we had to cut this bigger hole in the roof, and the rain was falling, and rain was coming into this, water was coming into this room, and it was pouring. It was flooded. It was pandemonium. We had to cover these with plastic. Even the UPS, the new one that was here, we had to cover it with plastic. The old equipment was already outside, but we were concerned about the floor because we didn't know what was actually underneath this thing. And so it was kind of starting to feel a little soft. And we were getting worried, you know, we may actually fall through.
Oh dear.
So we decided then to actually on one side take up the really soft chipboard. We discovered it was chipboard. We took that off and put a lay down PVC pipe, and it was fantastic. It was brilliant. So let's have a look inside.
And you said the name of this is?
Oh, this is the transmitter, and this is the digital receiver. You can see, I should mention that green is my favorite color. It is, for many reasons. I like to see green grass, I like to see green buttons, that means everything is okay. And you can see a lot of green. Like I mentioned, this is the transmitter. Inside here is a magnetron that generates a lot of the radiation that goes up in there. This is really dangerous stuff. No one, absolutely no one should be in this room without a Met official. Nobody. You can put your life at serious risk in here. Now, over here, like I mentioned, it's a processor, a digital receiver, and this baby down here is basically puts a lot of pressure in the waveguide, essentially. There's actually a very high pressurized waveguide, so the radiation can transmit through the waveguide. You have any questions?
Yeah, what do you have to monitor this system daily? I'm seeing a track sheet down here.
Yeah, this is just, when we do maintenance, we just take logs of certain measurements and serial numbers of objects that are actually in here. And so that for quick reference, or any other material you have in here, it's actually a touch screen.
And the system before it was not this size, so you didn't have a screen in the cabinets prior to this?
No, we didn't have this. It's kind of fancy. The reason why it's flickering because there's a radio frequency coming out of here that's actually causing interference. When we close it, see it stops. Again, that's why I mentioned no one should be in here unless you're supervised by Met official. As you can see, everything in green. This is on yellow because we're actually doing some testing on the digital receiver for quality assessment. So that's why that's on the yellow.
Leading to the top of the cockpit is a single ladder which plays a critical role in connecting the dome to the studio, housing the equipment of the weather radar. Mr. Best also provides some information on this.
So we have this ladder leading to the dome. Let's get some more information on this, Sabu.
This ladder here, this is the stairway to heaven. No, just kidding. So there's a ladder that comes up into the dome so we can, so you can get access to the reflector and the waveguide and the other various equipment that's in there. Unfortunately, I can't open it for you because the system is live and the dish is spinning.
Right.
If I try to open it, I have to turn the system off because there's a safety key inside here.
Okay.
So, but more importantly, I want to show you something because in the video that we took and we shared with you, the original hatch, this is not the original hatch. The original hatch, you can still see the old mark from the original hatch here. It was all metal, but it was really rusting and water and air was seeping through and we were getting a lot of drips, moisture into the room. That's not good for this kind of equipment. It just isn't. And so during that great process, we took out the old one and we replaced it with aluminum. It's still metal on the top, but this is aluminum, so it's not going to rust. It's a good thing. So we're thinking about, like I said before, you think about the future. In any project, structural upgrades you're doing, think about the future, the long run. How is it going to be viable? Okay. In the videos that you will see, water was pouring coming here every time the rain was falling. So we had this huge plastic on the ground, propped up with wood at the sides, so that the water would collect in the plastic. Because imagine you can't get buckets big enough to catch it. So we had to come up with a really good idea. Just catch it in a plastic kind of massive container.
I'm sure to carry out this type of reconstruction would have cost the government a bit. Can you speak to those financial figures?
Yeah, the entire project was like $3.4 to $3.6 million. The actual replacement of the sheets and the repairs to the base ring, which you'll see really nice photos of that. You'll see photos of my staff and myself even helping to sand and paint them because we wanted the project to move really quickly. The structural upgrades itself was around $150,000 to $200,000, which is part of the $3.4 to $3.6 million.
And you would say it's all worth it at this point?
It is worth it. The system is fantastic. We're enjoying it, and this is actually over a year because I mentioned it's 2022. We're 2023, so we're going in a year and a half since its operation.
And I'm seeing another structure over here, the importance of this, and what is it for our audience?
Okay, so these are UPS, two of them, uninterruptible power supply. It essentially what it does, if the power goes off, these systems will kick in and keep the system running until the generator kicks in. You have to have them. Now, the really cool thing about it is that we learned, like I mentioned, we learned from the past. And the old system, we had one UPS, not these, an old one, and there was a situation where it failed. And so when the UPS fails, you cannot function the radar. You can't. You need to have it. And so we were down for months while being repaired. And so what we set up here is a redundancy. They're tied to one another. They can see one another. They're sharing the load. But if one goes off, the other one take control. That's what we need, that redundancy. That builds the system redundancy. And it can be durable right through the times.
And now we're here at the control tower. Would that be the accurate term for what we're seeing here?
Not bad. It's more like these servers. Again, we have redundancy here again, because we learned from the two servers in hot and cold here that actually taking the data from a single processor to generate products. This laptop is just used for us to control the system if we want to, or we can log in and actually see the system functioning. Like I said, my favorite color is green. The yellow I mentioned before, this red is referring to actually something that's coming from the UPS, which is about a signal not coming. We're aware of that. That's not the radar. That's actually not the radar.
Okay.
All of this is the radar, so we're good to go. So we can log in remotely and see if the radar is healthy. If we need to come address something, then we will know what we need to walk with, because the spares are not here at this location. And so this is now, it's Barbados, like I mentioned before, 400 kilometers out. So you can see Trinidad there and the other islands of the Guadeloupe. And there's nothing much out there. It's pretty dry today, and we've been dry for a few days, even though there's still some spot showers coming through in the central and northern parts of the island occasionally.
Should there be any event of a bigger system coming through, what would we be seeing on the screen at that time?
This is the legend you can see here, less intense, more intense here. You'll see a lot of colors in here. It doesn't really take a lot to interpret in skill. We got some tutorials, and a lot of tutorials you can view online about how to interpret radar imagery and radar data. It's not that complicated. And then you're really enthusiastic about it and you'll love it, you'll learn it pretty quickly.
You also mentioned that you're involved in coding with your team at the airport. Let's talk a little bit about that as we're here at the computer system.
So we do a lot of software development, and actually all of the software that actually runs the entire organization in the operations Met Office was designed by the staff itself.
Wow.
And so it's really, really good.
That is quite impressive.
Yeah, it is. It happens over time. I mean, the main one is called apparatus. I remember a few years ago when we were designing it, we want to come up with what name we were going to call it. And so because it's many components that come together as one, it seemed like that's what an apparatus is. Many pieces of things that hooked up together and functions as one thing. And so it has one giant software that functions as one entity with many components in it that can function independently. With built-in artificial intelligence, that any of the components that fails, it restarts it by itself, kills it, restarts it, reports it. And that's key. So we don't need to monitor it.
Meteorology is an amazing science. But what does it take to become a Met Officer, or even the acting Chief Met Officer? Let's hear from the acting director of the Barbados Met Office on what's needed.
I remember way back in school, not until how many generations that was ago, it was this misconception, and I think it still is now, maybe to a less extent, that geography is one of the main requirements for the field of meteorology. It isn't, okay? It is useful in a sense, but very tiny. It isn't. There's math, physics, and now that everything is moving into the computer age, artificial intelligence, software development, computer science is a very big, very, very big component that's emerging in the field.
What do you love most about what you do finally?
New projects, new ideas, changing what's there now, destroying and recreating, making something new, getting better, getting others involved, letting them love it, let them be a part of it. It is for them, it is for the country, it is for the people, not for me.
We've completed the tour of the Doppler Weather Radar, and now we're heading back downstairs, but our team had a few more questions for Mr. Best.
Okay, let's go down. You know, they say going down is supposed to be easy, but it's sometimes not, because you can see the ground coming.
Oh my gosh, don't remind me. Sabu, before you go, just a few burning questions.
Wow.
How do you even predict a hurricane?
Okay, so there are many tools you use, not just the radar. There's observations, there's numerical models, there's satellite imagery. There's many things that you use together in conjunction to make a prediction into the future. Remember, if you're not aware, that a radar is not to predict days into the future. A radar is a tool used for nowcasting, more or less. It enables you to make good predictions of 1 hour, 2 hours, maybe 3 hours into the future. To some degree, maybe a 6 hour, but that depends on the situation, okay? So it's not just the radar, but many, many things that come together, particularly the numerical models. That helps a lot.
Before we leave, final question, I promise.
That's okay.
I know one of your passions is empowering people and young people in particular. Would you say there's a need for more young people to get involved in Met science?
Not just Met science, but yeah, I'll be biased to Met, obviously, but young people in general. But let's stick to your question, Met science. Yes. Young boys, young women, yes, the Met science is evolving, and particularly in climate services. Climate change, as we know, is happening. We're already really hot already. We're seeing increasing trends of temperatures happening across Barbados and the region. We need to understand, push the science into the future to understand what's it going to be like 5, 10, 15 years from now. Not just 100 years. You tell someone about 100 years from now, they say, well, I'm going to be dead. Why do I need to know about that? But yes, you still need to know for your future generation, but we also need to know for the near term. That near term is important because once you have an understanding on small, local, hyper-local scales, what may happen in the Bridgetown area, in elevated areas, in Christchurch, where they do, or St. Philip, where they have a lot of planting and stuff going on, you understand those microclimates, what will happen. You can then, policymakers, whoever makes decisions, can then make the decisions that are required now to mitigate the impacts of what is to come, or what possibly is to come. People think you make a climate prediction that it will necessarily unfold. You look at what are the possibilities and you put things in place to help mitigate the possibilities that can happen. That is progress, that's human development, that's intelligence.
So many nuggets of wisdom in such a short space of time. I know your time is important, Chief, but I want to thank you sincerely for joining us for this particular special.
You're welcome, and you're welcome.
Well, that's it for this special on the new weather radar in Castle Grant, St. Joseph. I'm Michron Robinson. Thank you for joining us.